Let's try to operate these following complex numbers with their respective operations. The first one is to add them, second is to subtract, the third one is to multiply, and of course the fourth one is to divide complex numbers here. Now you can use the illustrated formulas represented in the or presented rather in the previous videos, but of course you could always try to apply here the necessary processes for them. Let's start with the first one here. So if we're going to add them, simply try to remove the grouping symbol if you can. Plus 5 plus 2i, and plus, sorry, that's automatically minus 3 minus I. And then group the real part and the imaginary parts. So you have 5 minus 3, or you could write it like this. Let me write it like this so that I could actually discuss it for carefully. But of course, you can automatically answer if you can. 5 minus 3 is 2, and then you will have here plus I, or 1i, because that's 2 minus 1. Again, you can also try to use the formula presented before for your answer. Now, for the next here, we are going to subtract them. So we could again remove the grouping symbol. Negative 4 plus 5i, that's plus 2 now, and plus 3i. So you'll have here negative 4 plus 2, take it off the moving of grouping symbols, and you will have here plus 5i plus 3i. So you will have here negative 2 plus 8i. Okay? So it's very clear for addition and subtraction. Simply regroup them or add the real parts and the imaginary parts. But for imaginary part, the coefficients alone. Okay. Now, let's proceed to the third one, as this uses multiplication. When we multiply that, let's simply use the FOR method, or again, the formula we have before, but I'm going to illustrate here the longer method for further discussion. So you're going to have here the FOR method, so 2 times 3, or you could have it like this. Okay, I'll be writing that step by step. So 2 times 3, then use plus, so 2 times negative 2i. Don't worry if I'm using plus, because later on the negative will still prevail in the multiplication process. Plus 3i times 3, and then you have here plus 3i times negative 2i. This means this is actually 6 minus 4i plus 9i, then minus 6i squared. We know that I is actually equal to the square root of negative 1. Hence, I squared is the square of that, the square of the square root of negative 1, which will give us negative 1. So with that here, that's 6 minus 4i plus, or you can now start regrouping the i's here. Okay, so let me regroup them. Yeah, I will start with the positive, so 9i. I'm gonna rearrange them for easier representation later on. Minus 6 times negative 1 as presented here. So this means 6 plus 6, because this is now plus 6, and then plus 9 minus 4i. Okay, or again, you can automatically add them here if you can, or here as well. Nevertheless, I have here 12, and then you have here plus 5i. This is the product of the two complex numbers presented a while ago. I'm using this because there is a shortcut, again as mentioned, for that, so you can have you can leave with the illustration and look into these portions if we have the same illustration. Okay, now how about the division that we have here? So you have 1 plus 2i over 2 minus 5i. As mentioned in a video discussing division of complex numbers, we need to make sure that our denominator here will not contain imaginary unit. Hence, we're going to use here the conjugate of your denominator. The conjugate will use, okay, the same first term, the same second term, but opposite sign. Since this is minus, you will have to use add or addition here. Hence, this is 1. Sorry for that. Let me rewrite that. 1 plus 2i over 2 minus 5i times the conjugate of your denominator, 2 plus 5i. And to make sure this is just equal to 1, the same thing will be added, or I mean placed on our numerator here. So, you will have here the product of 1 plus 2i and 2 plus 5i for our numerator, and our denominator, that's 2 minus 5i and 2 plus 5i. So let's continue multiplying them. So let's just simply copy first our I can automatically write it here. Let me make this or transfer here at the bottom, because I need to use the FOIL method for our numerator. So 1 times 2, so you have 1 times 2, and then 1 times 5i, then plus 2i times 2, and plus 2i times 5i. On our denominator, difference of two squares here, that's 2 squared minus the square of 5i. Our numerator will have 2 plus 5i plus 4i. You have here plus 10i squared all over 4 minus 25i squared. Again, I squared is negative 1 here. So further, you'll have 2 plus 9i. This is 9i. Then plus 10 times negative 1 over 4 minus 25 times negative 1. So we will have to simplify this here. That's 2. This is minus 10, right? So you have minus 8 plus 9i over 4 plus 25, which will give us negative 8 plus 9i over 29. As you can see, our denominator is a real number, no longer containing the imaginary unit I. So these are the results, or this is how we divide or get the quotient of this expression here. So we have here division, we also have multiplication, and you also have here subtraction and addition of complex numbers. So if we have situations where there are combinations of 2 or more, simply use the correct process of operations, order of operations rather, still PEMDAS if you can. Then make sure that you will consider the existence of imaginary unit, specifically when you reach I squared, just like this. Thank you very much for watching.